All right, we're looking at hydrogen. Hydrogen is the first element on the periodic table, the most abundant substance in the universe, and arguably the MVP of the cosmos. It's the fuel that powers stars and the smallest, lightest atom, and it is the smallest, lightest atom in existence. Here's a breakdown of what makes hydrogen so unique, from its atomic structure to its potential as a clean energy source. 1. Atomic structure and properties. Hydrogen is remarkably simple but incredibly potent. In its most common form, an atom of hydrogen consists of just one proton and one electron. The symbol is H. Atomic number is 1. The atomic weight is 1.008. The state at room temperature, it is colorless, odorless, tasteless, and highly flammable gas, as in H2. Density, it is roughly 14 times lighter than air, which is why it was famously used in early airships, though its flammability eventually made that a risky choice. Ooh, make me jump a little bit. I got alarms for every hour just to kind of like keep me on track doing different things. So I don't get too distracted doing, like one singular task. Anyway, so yeah, using that in the dirigibles, was it like God, what was the one that crashed? The Hindenburg. I was about to say Heisenberg. The Hindenburg. I think that used hydrogen. Not a good idea. Went up in flames. A lot of people died. So a little risky. Yeah. 2, the 3 isotopes. While most hydrogen, whoa, oops. While most hydrogen is standard, it has 2 heavier siblings that are crucial for nuclear science. Protium, or 1H, the standard version, 99.98% of all hydrogen. Deuterium, 2H, contains 1 proton and 1 neutron. It is used in heavy water for nuclear reactors. Tritium, 3H, contains 1 proton and 2 neutrons. It is radioactive and used in nuclear fusion research and self-illuminating exit signs. 3, the colors of hydrogen, or energy production. Hydrogen is a clean burning fuel. When you burn it, the only byproduct is water, H2O. However, it doesn't exist on its own on Earth. It must be extracted from water or methane. The industry uses a color spectrum to describe how cleanly it's produced. If the color is gray, we have a production method for the gray hydrogen. It's extracted from natural gas or methane via steam reforming. The environmental impact is that there is high CO2 emissions. A blue color production method is the same as gray, but the carbon dioxide or CO2 is captured and stored through CCS, carbon capture systems, maybe. Environmental impact, low net emissions. Green hydrogen is produced via electrolysis, powered by renewables such as wind or solar. Environmental impact is 0 carbon emissions. And then pink hydrogen also has 0 carbon emissions and is produced by using nuclear power to drive electrolysis. Key uses today and tomorrow. Hydrogen isn't just for the future, it's already a massive industry. Industrial uses. Most hydrogen today is used to create ammonia for fertilizers and to refine petroleum. Fuel cells. Hydrogen fuel cells generate electricity by combining hydrogen and oxygen with water as the only exhaust. They are currently used in buses, trucks, and even space shuttles. Rocket fuel. In liquid form, hydrogen provides the highest specific impulse or efficiency of any traditional rocket propellant. Steel production. Emerging green steel tech uses hydrogen instead of coal to remove oxygen from iron ore, potentially decarbonizing a massive global industry. That's good. 5 challenges to consider. As much as we love hydrogen, it has some personality flaws that make it tricky to handle. Storage, because it's so light, you have to compress it to extreme pressures, like 700 bars, or chill it to negative 253 degrees Celsius to store enough of it to be useful. Leaking, hydrogen molecules are so tiny that they can leak through solid metal pipes and even make some metals brittle over time. Efficiency, converting electricity to hydrogen and then back to electricity via a fuel cell loses a lot of energy compared to just using a battery. All right, is hydrogen.